Alright guys, this is section 8.2, graph simple rational functions. Now I know it says simple, and it really is, I promise. So it says graph inverse variation, and it says what does it look like? So when I have a graph, so let me just put a quick graph up here. When I have a typical graph that looks like this, when I graph an inverse variation, it's going to look something like this, where it has a line going this way and going this way. Or vice versa, it could be up here and down here, but usually it's across from each other. Now, also, if you notice that this line never actually touches the black line, so we have asymptotes going here and here in our basic function. Now, this is called a hyperbola. And an inverse variation is an example of a rational function. And we have been solving and multiplying and dividing and adding and subtracting rational functions for the last few sections. So it's going to look something like this. F of x equals p of x over q of x. Now in our equations that we've been doing, we have had something like x squared plus 2x plus 1 over x times x minus 1. Something like this. This is what we've been dealing with. So if I'm looking at this here, and I say, what is my domain? I'm going to look at where all of my x values are. So I can't equal 0 because I have an asymptote there, but it looks like it goes to infinity up and infinity down. So my domain is going to be all real numbers, except x cannot equal 0. And now for range, we're going to do the same thing, except it's going to be y values. So I have a asymptote here at the y-axis. And so my range is going to be all real numbers, except y cannot be equal to 0. Woo, sorry, 0. And now it says, what are my asymptotes? So my asymptotes in this situation are the x-axis and the y-axis. Now, you don't always have necessarily asymptotes, but you should check to make sure you don't before. So, first example, we're going to look over here, and we have graph this thing. So my vertical asymptote is always going to be setting the denominator equal to 0. So if I set denominator equal to 0, then I have x is equal to 0. So I don't have to solve. I already have x is equal to 0. So my horizontal asymptote is going to be right here. Now, the next thing says horizontal asymptote. So if I have my horizontal asymptote, how I'm going to solve for that is I'm going to look at the degree of my variables. In this case, I only have one variable at the bottom, which is x. But if I were to have a degree or an x on top and bottom, I would know that I need to take the leading coefficients. So if, for example, if I had 2x over 3x, they both have power 1, so I'm going to take the leading coefficients. So my horizontal asymptote would be at 2/3. Now in this case, since since my power is higher in the bottom than it is on the top, my horizontal asymptote is just going to be y equals 0. Now, when you're doing vertical asymptote and horizontal asymptote, you have to have it as an equation. It has to be x equals something and y equals something. It cannot just be 0 and 0. That doesn't make any sense. So, my horizontal asymptote in this situation is going to be y equals 0. So it's going to be down like that. Okay, next thing is x-intercept and y-intercept. This is normally what I'm going to find, and then I'm going to plot a couple points. But my x-intercept has to be on the x-axis, which is an asymptote, so it can't equal that. And same with my y-intercept. So I can't find an x-intercept or a y-intercept, so I'm just going to plot points. So I'm going to say my first point is x is equal to 1. So if I put x is equal to 1 over here, then I have y is equal to 4 over 1. So y equals 4. So my point is 1, 4. And then I'm going to pick x equals 2, do the same thing. Y equals 4 over 2, so y equals 2, so my point is 2, 2. And then let's pick some negatives, so let's pick x equals negative 1. So I have y equals 4 over negative 1, so y equals negative 4. So another point is negative 1, negative 4. And then x is equal to negative 2. So I have y equals 4 divided by negative 2. So I have y equals negative 2. So I have negative 2, negative 2. Now I'm just going to step 3, graph my hyperbola. So I have 0.14. So 1, 1, 2, 3, 4. Here, 2, 2. And then I have negative 1, negative 4. And negative 2, 2. And then I'm just going to, I know the general shape of my hyperbola, so I'm going to go up that way and down this way. And same with this side. It's going to go like this. Now the last thing I'm going to look at is my domain. In my domain, it's just going to be all of my x values. And since I have a horizontal asymptote at x is equal to 0, then it's going to be all real numbers except x cannot equal 0. Okay, so next problem. Now I have something like this. So I have this weird plus 2 at the end. And how I'm going to get rid of my plus 2 is I'm going to find a common denominator and make this one equation. So I'm going to say y equals 1 over x minus 3 equals, or plus, sorry, 2 over 1. Now my common denominator is going to be x minus 3, so I'm going to multiply the top and bottom by x minus 3. So then I'm going to have 1 plus 2 times x minus 3 divided by x minus 3. And then I'm going to distribute here. So I'm going to have, this is going to equal 1 plus 2x minus 6 over x minus 3. And then I can combine this, so I have 1 minus 6, which is going to be negative 5. So I'm going to have 2x minus 5 over x minus 3. Now the reason I put my x thing first is because I want these to be in standard form. So I want, if I have an x squared, I want it to be x squared, and then x, and then no variable. So I'm going to leave it like this. All right, vertical asymptote. Remember, is we are going to set the bottom, or the denominator, equal to 0. So I have x minus 3 is equal to 0. Add 3 to both sides, so I have x is equal to 3. So my vertical asymptote is x is equal to 3. So it goes here, and then it goes down. Ooh, sorry. Like so. Now my horizontal asymptote, again, I'm going to look at my degrees. So this is x to the first power and x to the first power. So since these are the same degree, I'm going to take my leading coefficients, and there's an imaginary 1 here. So my horizontal asymptote is just going to be y is equal to 2 over 1. So y equals 2. So I'm going to go up to y equals 2 and make my horizontal asymptote. Now, for the x-intercept, I am going to set the top equal to 0. Now, the reason this works is because I want y to equal 0, and if I have a fraction with 0 on the top, then no matter what, the whole fraction is 0. So I can just set the top equal to 0. So I have 2x minus 5 is equal to 0. Add 5 to both sides, so I have 2x is equal to 5. So x is equal to 5 over 2, or 2.5. So I have 2.50 is my x-intercept. Now my y-intercept, I'm going to make x equal to 0. Now, the reason I'm making x equal to 0 is because I want to be somewhere on my x-axis, or on my y-axis, sorry. So if I set x equal to 0, then I have 2 times 0 minus 5 divided by, and remember this is x equals 0, divided by 0 minus 3. So I get negative 5 divided by negative 3, or this changes to 5/3. So since x was equal to 0, then this is my y. So my point is 0, 5/3. So now I'm going to plot these 2 points. So I have 2.50, so here, and then 5/3 is like 1.7. So I have 0, 1.7-ish, so it's about right here. So I have this side of my hyperbola. Now, the real problem is that I need this side, but I can't just graph it randomly. I need at least one point so I know kind of where the graph is supposed to be. So I'm going to look at my vertical asymptote, which is at x equals 3, and I'm just going to pick x equals 4 so that I get something over on this side. So if I say x is equal to 4, then I can say 2 times 4 minus 5 divided by 4 minus 3. So I have 8 minus 5 over 4 minus 3, which is 1. So I end up with 3 over 1. So at x equals 4, my y is 3. So I'm going to plot the point over 4 up 3. So this half of my graph is just going to be like this. So, sorry. So this is how it looks. I guess I'm changing colors. There we go. And so now the only thing I need to do is look at my domain. And since I have a horizontal asymptote at y is equal to 2, then that means that I need my x values, or sorry, we're looking at domain. So I need to look at x values. And x cannot equal 3 because I have an horizontal vertical asymptote right there. So it's going to be all real numbers except x cannot equal 3. Okay, I know that was a lot to take in, but I want you can rewind the video and watch it again while you're doing this problem, but I want you to do this problem on your own. So, this is what I want, and you don't have to find a common denominator since you don't have any plus something over here. Since it's just a normal fraction, you can just do it without having to find the common denominator first. So once you finish, I want you to check your answer, and you should have a vertical asymptote at x is equal to 2, a horizontal asymptote at x is equal to 1. Now you should have paused this and gone back and tried to figure out how to do this before I'm telling you the answer. Your x-intercept is going to be x is equal to negative 1/2. So your point will be negative 1/2, 0. So you'll have negative 1/2, 0 here. And then your y-intercept is going to be setting x equal to 0, which is going to make y equal to negative 1/4. So you're going to have 0, negative 1/4. Oops, sorry. This point here should have been right here. And then 0, negative 1/4. And then you have your graph here. And then you should have plotted a point. I plotted 3, and so I got 3, 3.5. So my point was here. You could have plotted any point, but you needed a general guideline of where to go. And so your graph should look something like this. All right, have a good night.